Hey, hello, it's me, SolarLune. Hi, hi, hi. It's been a while since the last stream, and it's been a while since the last update video. I've been working on this game, and it's been shaping up, but I've just been kind of busy, really busy with just a lot of other things. But things are still going really well. Between the last stream and this, or last update video and this one, I moved to a different technology. I moved to WASM, WebAssembly, as I recall, for the game. So basically, before it was running through an interpreter written in Go that ran Go code. Now it's running through a WASM runtime written in Go. So it's still running in Go. It's still the game is still running in Go. The language that is written in is still Go, but instead of being interpreted as a Go script directly, it is now running through a WASM runtime. So it's being compiled down into WASM WebAssembly. So yeah, it's running really well. Overall, there's not too much difference from the last update video. It's basically about the same. Not everything is implemented, but a lot of it is, and so I'll kind of show the differences, what little differences there are. These little pickups icons are now 2D rendered animations, which are cool. Very Donkey Kong 64, very, Mario coin in Mario 64, just standard pickup stuff. Just, looks pretty good. Not exactly perfect. The outline is a little thicker on the bottom, so it looks a little weird, and it's a little plain, but yeah, it's fine. It's fine. Ziplining is still in. That still works. Yeah, hanging off of ledges and stuff is still working. Character's still fully animated. He's still got most of his moves, all of his moves. I guess all of his moves. He can still slide. He can still hang off of stuff. So really, there's not really any difference, but something that you will see that's a little different or significantly different. Well, actually, one more thing before I move on. I added the ability to write shaders. So basically, you can write a Kage shader and load it into the game now. So that's working well, which is cool. So very nice, very nice. Everything's roughly about the same. But one thing that's different is when we go up here and stand and look down at the scene, our numbers are much better than they used to be. Rendering is way better. It's under 4 milliseconds, and update is about 1 millisecond, which is good. That's a lot better. I'm still looking to get it lower if possible, but that's a lot better, a lot better. If you take a look at the old update video I had, it was on the order of like 5 to 10 or I'm sorry, 6 to 8 or so milliseconds for total render frame time, and update frame time was about 3 to 4 milliseconds. So it's way better than it used to be. Lighting is also better. So it went up to 2 to 3 milliseconds. Now I've gotten it down to sub 1, which is really good, really good. Just like, slowly hacking away at like minor optimizations for like rendering and stuff like that, and it's shaping up. It's running a lot better, a lot more smoothly, and a lot of that has to do with running through a WASM runtime as opposed to being running through an interpreter. But a lot of that, some of that is also just me optimizing things and being like, maybe I shouldn't be profiling something for every vertex of every triangle in the render process. Maybe I should move that out so that it's not so time intensive, and just minor little stuff that ends up adding up, and now we're getting a much better frame time. So very cool, very cool, very nice. So now the thing that's kind of interesting, if we take a look at the way the game actually looks, I'll go into this a little bit more in detail. But at its core, the game is entirely implemented in like the plugin system. So basically, if you wanted to take the game and add it, make an entirely different game, that's completely within your power, because the entire game is here. The update code is here, the draw code is here, and it just all kind of spiders out from there. So if you want to change anything, you can. So that's really cool. That's really cool. Something that I kind of a different kind of paradigm I approached for this particular game, or this particular system, is I'm sorry, I'm just looking at something else. The paradigm that I am approaching for this particular kind of game development system is a little bit interesting, because basically, traditionally, you have an object-oriented design, where basically you have things like, let's say, a model or a light. These are objects that inherit a base object type like node. So you have a node that represents something that has a three-dimensional location in space. Maybe it's called an entity or something like that, or it could be component-based. But let's just say it's an object-oriented approach, where you have a node, and then you have under that like a light or a model. Rather than that approach, that approach works, but because my game is developed in such a way where the game state is internal to the system, and what I'm doing is modifying that state through this code, I don't really want to have a lot of different object types. I don't want to have a node and a light and all this stuff, because that kind of makes me have to reuse, create a lot of extra code. I'm not really explaining it that well, I guess, but at its core, let's say if we go to this, in this kind of a situation where, let's say you have the player shadow, and you're trying to set the visibility of the shadow. If the shadow was a model and the model is a node, then when you go to access the shadow's variables or functions, you would have all of the functions for the node in addition to all the functions for a model. That can be kind of messy, because you have a lot of stuff. It can get very, very big, very, very deep, and kind of hard to parse and understand. So and also it's more code on the internal, because you have now type checks, right? Where it's okay, a model is a node, a light is a node, a sunlight or a directional light is a node, and that kind of just additional stuff can be a little extra cruft. If you take a look at, for example, the node type in Tetra 3D, which is the base backing. Here we go. Yeah, you take a look at. Can I not? Why can't I? Okay, well, hold up. Okay. I'm not sure why I can't jump to... Very interestingly, you know what? Never mind. Let me do it this way. Here we go. Okay. So this game is based on Tetra 3D. It's my own custom 3D renderer. Built on Ebbie engine, so I do all the 3D stuff myself. So a node in Tetra 3D is basically a 3D object in space, and in Go it's an interface. Well, in Go it is a struct, and it also is an interface, because different things embed nodes to become interactable. So for example, a model embeds a node so that you have access to all of the functions like name and string and ID and all these functions on the node, so that I don't have to implement them on the model. I don't have to implement them on a directional light. I can just implement them on the node, embed the node in the model, and now the model has these functions. But this is kind of trash, because when an interface, in order for it to be generic, you have to use an interface. So you have the node struct that is the fulfillment of the contract, and you have the inode interface that is the contract itself, which means now you're kind of maintaining two different sets of functions. And you can, for example, make the inode interface have all of these functions, and then you have the node struct have all of these functions, but then you can miss a function in the inode and add it to the node, and you would never know. You wouldn't know, because you go to access the node directly, and the function is there, and it's okay, cool. But if you ever access the node generically, the node may not be there. And so it's just that kind of stuff is it's a little weird. It's a little janky in a sense. like interfaces are a good approach to solving kind of the question of generics in some ways, but it's not great because it's not a hard-coded contract. It's not like a node struct in Go forcibly implements an interface. It just does that when you give it a function, or give it all of the functions of an interface. Now it does fulfill the interface, but obviously if you leave out a function in the interface that is present on the fulfilling struct, you would never know. It would just, it's not going to come up. So that's kind of weird. You know, you have an interface set that's kind of, you know, you gotta maintain, like I said, two different sets of functions, one for the interface, one for the actual implementation of these functions. It's not great. I don't like that solution as much. So what I ended up doing, I'm rambling a little bit, but what I ended up doing was basically going with a different approach where nodes represent an object in 3D space, and things that would be extensions of that, like let's say a camera, or let's say a directional light or whatever, those things are accessors. So basically an accessor is like a trait. It's something that is present on the kind of node that implements that functionality. So for example, the shadow here, the player shadow, is a node, a T3D node. And so if you go to look at T3D node, you just have generic node stuff like, does it exist? Can I clone it? You know, can I get the root of the hierarchy that the node is in? What scene is it in? Can I get its collider if it has one? Just basic stuff, setting the position, moving it, that kind of stuff. But then if you wanted to access, like for example, here we go. If you want to access like its visibility, that's something that would be present on a model and wouldn't be present on, let's say, a camera. Then you can access model. And so the access model function returns a model accessor, which allows you to have the functions that only models have access to, like the dimensions of the model, the color of the model, whether it's frustum culling is enabled or not, whether it's visible or not, what mesh it has, that kind of stuff. Really cool. I like this approach because it segments things out, so you don't have access to everything in one big list. It's like, okay, well, if all the model stuff lives in access model or a model accessor, all the camera stuff lives in camera, the camera accessor, which is cool. Access camera gives you the camera accessor, and now you have all of these things like clearing the camera buffer, rendering a scene, getting the color or depth texture, setting the field of view, checking to see whether a point or model is within the view frustum of the camera, all that kind of stuff. So very smooth and easy. I like it. And if you try to access an accessor on a node that doesn't support it, it just won't work. It's just gonna naturally be like, you know, you tried to use this thing and it's not it. Yeah, you can check to see if it would work by checking I didn't implement it on this. I implemented it over here. Checking the is okay function. So I'm not sure about this particular system, but I'm not against it. I'm just not sure if I like it. There we go. It's, yeah, just kind of a little shorthand to basically say what type is the node and is it the expected type. So you can say like, oh, you know, if ps dot is okay, then you can set the visibility of the model. So I like that kind of approach. It feels a little weird, but at the same time, it feels also very sleek in a sense because all of the stuff is under one place, and it also segments the code where it's like, okay, all of the things for nodes like parenting or moving or setting their rotation, it's all under node. You don't have like, you know, the concept of like model rotation being different from node rotation or camera rotation. It's just like, no, nodes do all node stuff, and then the accessors handle the additional traits. And maybe trait would be a better word than accessor. Although I kind of like accessor, the accessor / access verb, because that lets you that puts it in your mind that like all of these things are ways to access a specific feature. But feature, trait, accessor are kind of all the same words for this. Maybe I'll do like trait, get trait model, get trait camera. I don't know. Get camera trait, get model trait. I don't know. Those are ideas. That's not that important. The wording, the concept is what I think works really, really well. It's simple, and it's not just to underline it. This is not a usual trait system or component system where you can add things to a node to make it that thing. Like, oh, it's a node. Like a camera is just a node with a camera trait. It's like, no, a camera is a camera. When a camera is its specific thing, but when you go to access it in the scene hierarchy, it's just a node that has a data in the camera accessor. It's a little bit of a distinction. Like basically, you would never have a node with multiple accessors. It would only ever be one, whatever it has for the kind of node it is. So if you have a point light, you would only be able to access the point light accessor. Everything else wouldn't work. You would never be able to add a different accessor to the point light to make it something else. That's not how it works. So it's not really a trait system or a component system like most engines. It's kind of just a way to access specific features on specific types of nodes, and to do so easily and without a lot of fluff and problems. It works well. The performance is solid. I'm a fan of this. I'm a fan of this. I think it's really easy to get into. I think it's performant enough. I think it's simple. It's and I like how it kind of informs you as to what you're, like you look through the node function list and you kind of understand all of these things. This is super straightforward and like descriptive of what it does. And of course I'm gonna document all this stuff eventually. But yeah, it's like, this is not hard in my opinion to understand, because all of these things are pretty straightforward. Like, it's pretty straightforward. So anyway, that's about it, I guess. I'm happy with the current state of affairs. I'm super glad to have made all this progress. It's been taking a long time, I know, but I'm really happy every time I make progress and like refine things. And this particular approach to this was one I actually tried before and thought it was just too slow, because I was trying to serialize and send too much data back and forth between the WASM barrier. So WebAssembly runs in a it's fast, but it runs in basically kind of like a, separated container from the main host process, the game, whatever application it is. So you have to send data back and forth through like specific means. You can't just access the data on the host or access the data in the WASM runtime. And you do that by basically like either calling functions and passing arguments, or by allocating memory and sending bytes through that memory kind of barrier. So I was doing a lot of like serializing, putting data through that memory translation process, and that was slow. So since then, I basically have approached this kind of differently, where all of the data in the game lives on the host process side, and the game application that gets compiled, the WASM WebAssembly application, the compiled thing that gets run in the runtime. When you go to access like a model or a mesh, you're not actually getting it in the runtime. You're basically just getting a number. You ask the host process like, hey, can you load this scene? And it says, okay, here's a pointer to the scene, It's just a number. It's just like the number 1 or the number 3, whatever position in the host process's resource state like array that the scene lives in. So when you say, okay, well, give me the name of the scene, you're just calling the function like get the name of a scene and passing the number 3. and it's like, okay, here's the name of the scene. So it's much faster because I'm doing as little serialization and deserialization of data as possible, which results in a game that is performant and also extremely easy to code, and also that runs really, really well. And yeah, I'm pretty happy with this. It feels very much so like kind of the best of all worlds. And compiling this down to WASM with the default Go runtime is literally like instantaneous, which is fantastic. You can see me, for example, if I say, okay, I've done this, you know, kind of thing before, but if I say, for example, I want the player to move faster, let's say, what's his max speed? Here we go, max speed. Let's say we want him to run faster. I have this right terminal set up so that when I save this, it will compile it to a WASM file using the default Go compiler. And once that happens, it will reload the game. So I'm going to press Control S right now. Click. And there we go. So that's pretty good. I mean, that's not bad. This is super fast. Like the Go developers, my hat goes off to them, because this is like lightning. It's crazy how fast this compilation is. And I guess part of that also is just because I'm not really putting a lot of libraries in here, because most of it is the engine, which is basically like that, like I mentioned, that kind of number passing, calling functions with numbers system. So, you know, it's nice and feels comfortable for the developer, but internally it's just passing numbers. So there's not a lot of like extra stuff to build. It's pure Go essentially. So this works really well. Happy with this. Runs well. Very fast to make edits. Yeah, I'm super happy with this. Like, maybe what I would like to do that would be just crazy is if I could like do some kind of partial compilation where it compiles to maybe multiple WASM files and it just reloads the one that's necessary. So for example, if I edit the player.go file, it just edits the player.wasm runtime, and then it just like re-instances the object or something, so that it doesn't have to like reload the entire game. That's a concept. I don't know. There's a lot that can be done to make this like crazily good, you know, low friction development workflow, but it already is fairly low friction. It already is pretty solid. So I'll just keep working on it. It's, yeah, really shaping up. Just have to kind of keep making progress. All right, well, that's the update video for today. Sorry that I went on a little bit of a tangent and rant. If you want to follow development, please do feel free to subscribe and check out my stream on twitch.tv and yeah, twitch.tv/SolarLune Twitch. And if you want me to make more videos on the internals of like how I implemented this stuff, please feel free to ask and I can do so. Alrighty, well, thank you very much for watching. I've been SolarLune, and I'll catch you guys on the flip side next time. See ya.